it's Ms. Backfish, and I am here to try and give you some assistance working on word problems, that basically give you systems of equations. These are all word problems in which you have two equations with the same variables, and so you have a system of equations, and then you can solve them by substitution or elimination or matrices, any of the methods we've used to solve systems of equations in this particular unit. So really different about the word problems than anything else we've done with systems of equations is the pulling the equations out of the paragraph, okay? So once you've done that, then you have a problem just like any that you did where you used substitution, or any that you did where you used elimination, or any that you had where you used matrices. So let's look at number 1 here. The first hint I want to give you about writing your equations is look at the last sentence first, because this is going to help you decide what your variables are supposed to be about. So the two things I'm trying to find, it says find the cost each of pie and of 1 pumpkin pie, of a blueberry, and I'm being asked the cost of a pumpkin pie. These are the two things I'm being asked. Okay, so I need to find those two things. So those are going to be my two variables. So let's call this one x and this one y. Sometimes I'll call it like b and p, something that goes with that letter. But let's just go ahead and call them x and y right now. And I apologize for the barking dog in the background. Okay, the first sentence, now we're going to go back and analyze what these sentences are telling us. And basically, the first sentence is just setting up the situation. They're selling pies for a fundraiser. Okay, great. The next, next sentence is as well. It's telling us there are two kinds of pies, blueberry and pumpkin. The next two sentences are our two equations. So this sentence, Carlos sold 12 blueberry pies and 8 pumpkin pies for a total of $240. That's an equation. Okay, so talking about what Carlos did, he sold 12 of the blueberry pies and 8 of the pumpkin pies, and this gives us the total amount of money he sold. Well, if we knew how much each blueberry pie cost, then we could do 12 times that amount and know how much money he raised selling blueberry pies. And if we knew how much each pumpkin pie cost, we could do 8 times that amount and know how much money he raised doing pumpkin pies. So, in other words, our equation is 12 times the cost of a blueberry pie plus 8 times the cost of a pumpkin pie gives me the total amount he raised. Okay, so now we have the next sentence. It's the one that's about Matt and what he sold. He sold 6 blueberry pies and 13 pumpkin pies for a total of $282. So again, this is about the money he made. So 6 times the cost of each blueberry pie will tell me how much he made off blueberry pies, and 13 times the cost of each pumpkin pie will tell me how much he made off pumpkin pies. And that means 6 times the cost of a blueberry plus 13 times the cost of a pumpkin, and we're told that his total amount raised was $282. So this is my system of this being a word problem. The only thing that the word problem part of it is about is you coming up with two linear equations. So really, this is kind of like if you just had a linear equation word problem, like find a linear equation about this word problem. And so we just have 2 of them. And one sentence tells me one, and the other sentence tells me the other one. And since we have 2 equations with the same 2 variables, that's called a system of equations, and we can solve it like we did any other system in Unit 3. So let's look at the next one. Okay, May's school is selling tickets to a fall musical. On the first day of ticket sales, the school sold 12 senior citizen tickets and 14 student tickets for a total of $336. The school took in $152 on the second day by selling 4 senior citizen tickets and 8 student tickets. Find the price of a senior citizen ticket and the price of a student ticket. So again, the first thing you want to do is look at the very last sentence. Find, and it tells me what I'm going to find. Price of a senior citizen's ticket, that's one variable. Price of a student ticket, that's the other variable. So I'm going to let the amount of money for a senior citizen's ticket be my x, of money for a student ticket be my Y. And then the first sentence is the only one that sort of sets up the situation. It says, May school is selling tickets to a fall musical. Then the next two sentences, each one of them tells me an equation. Each one of them is basically an equation, just in words. This one says, on the first day of ticket sales, the school sold 12 senior citizens and 14 students, and the total was this. Okay, so 12 at this rate, 12 senior citizens tickets plus 14 at this rate gives me a total of 336. And then I do the exact same thing with the next sentence. This sentence tells me the school took in $152 by selling 4 senior citizens and 8 student tickets. So 4 senior tickets, so 4 at this rate, plus 8 student tickets, 8 at this rate, gives me $152. And again, now I have my system of equations and I can solve it any way I want to. Alright, let's see if we can come up with one that's not about money. I don't know, they all seem to be pretty good about money here. There we go, let's look at number 5. State Fair is a popular field trip destination. This year, the senior class at High School A and the senior class at High School B both planned trips there. Senior class at High School A rented and filled blah, 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 blah. Okay. Looking at the end here, how many students can a van carry? How many students can a bus carry? That's what we're trying to find. So those are my variables. So I'm going to let V be number of students on a van. And I'm going to let B indicate the number of students on a bus. Okay, so looking back now, first two sentences here, State Fair is popular, and this year these two high schools went there. That's just setting up the situation. Now, the senior class at High School A rented and filled 2, had 2 times whatever number of students fits on a van, plus 7 times however many students fit on a bus, and that totaled 328 students. So that's the third whole sentence. That sentence is an equation. The next sentence is the other equation. High School B, and the A and the B don't really matter. I mean, they're just basically ways of saying they're different. High School B rented and filled 8 vans, so 8 times the number of students per van, plus 5 buses, 5 times the number of students per bus, with 300 students. That totaled 300 students. So now, there's my system of equations. And I can go on to solve it however I'd like to. I hope this is helping you. If it is, great. Basically, I don't want to do all the problems for you. So what I'm going to do is I'm going to ask you to go ahead and pause and try some. How about trying number 3? Number 3. Pause the video. Try setting up the equations yourself. And I'm going to go ahead and tell you how to do it. So if you're going to pause now. All right, now I'm going to go ahead and tell you. Looking at the last sentence, price of an adult ticket is one variable, price of a child ticket is another variable. So I'm going to let A stand for the price of an adult ticket. And I'm going to let C, and you can make it X and Y, it does not matter, be the price of a child ticket. The only reason I sometimes like to do letters that go with the words is because then there's no going back and forth and thinking, now what was my X, what was my Y? Alright, so Sarah Wong's school is selling tickets to the annual dance competition. That's just background info. Next, on the first day of ticket school sales, the school sold 2 adult tickets, so 2 times the cost of the adult ticket plus 14 times the cost of the child ticket gave them a total amount of money of $76. Then the school took in, on the second day, $98 is the total, by selling 7 times each adult ticket price plus 7 times the child ticket price. And there's my system of equations. Okay? If I were going to go ahead and solve this one, let's say I want to solve it, I probably would use elimination. The reason I would probably use elimination is that I would look at this and say, well, I don't have any place where the variable is alone with no number in front. So that means I don't have a place it would be easy to get that variable alone for substitution. You could do substitution. You could go ahead, like I believe, well, I know 98 is divisible by 7, so I could get A alone or C alone in this, or A alone up here. It's just that we tend to be attracted to places where it's already does not have a coefficient other than 1. I think, when I look at this, I think about this being 7 and this being 14. And I think, well, if this were negative 14, then these would cancel when I add. So that's elimination. So if I can make this negative 14, I will. And how do I make that negative 14? I multiply it by negative 2. So I multiply this entire equation by negative 2. So negative 2 here, and negative 2 here, and negative 2 here. So that gives me, the first equation didn't change at all. The second equation becomes negative 14a plus negative 14c equals negative 2 times 98 is negative 196. And then I can add top to bottom, and what will happen is that these two will make 0 c's. So I'll be done with c's. C is gone. C is eliminated. So that's why we call this elimination. 2 minus 14 is negative 12a. And 76 minus negative, or minus 196 is negative 120. And then I can find that a is 10. So that's a. And then I can go back and plug in a, any equation that has both a and c, and that would give me c, like maybe first one. 2 times 10 plus 14c equals 76. So 20 plus 14c equals 76. Subtract 20 from both sides. 14c equals 56. Divide both sides by 14, and c equals 4. So now I know A and I know C. I know that the cost of an adult ticket is $10 and the cost of a child ticket is $4. And that's my answer. Alright, let's do another one. How about number 7? Number 7 is a lot like number 15 that we just went over. So try to go ahead and hit pause, and then go ahead and create your system of equations for number 7. Alright, so let's assume you've already done that, and you're unpausing. So we know that what we're trying to answer is how many students can a bus carry and how many students can a van carry. So this time let's call X number of students a bus, and Y the number of students in a van. Why am I doing it differently? Just because maybe you prefer it that way. So now you've seen one of each kind. Alright, senior classes at High School A and High School B plan separate trips to the local amusement park. That's just giving us some context, what this problem is about. The senior class of High School A rented and filled 10 vans and 11 buses with 644 students. Alright, so that sentence is an equation. 10 vans, so 10, oops. This van's going to be first both times. I probably should have made van X, but that's okay. 10 vans plus 11 buses equals 644 students. The next sentence tells me that 2 vans and 14 buses gives me 648 students. And then that's my system of equations to solve. And you can solve it any way you want to. I'm going to go ahead, you might want to pause and try it. I'm going to do it by substitution. I'm going to take this particular equation and I'm going to solve it for y. So 2y plus 14x equals 648. Subtract 14x from both sides and I get 2y equals negative 14x plus 648. Divide everything by 2. And y is negative 7x plus 324. Okay? So now I know that y is equal to that. That means in place of y, I can write that. Not in the equation I just solved, but in the other one. So I go to the other equation, and 10 times y becomes 10 times all of that. Instead of y, I'm putting negative 7x plus 324. So this is me putting in this equation. 10 times y plus 11x equals 644. Let's use distributive property. Negative 70x plus 3,240 plus 11x equals 644. Negative 70 plus 11 is negative 59x. Let's go ahead and subtract this from both sides. And we have not a working calculator. This one does though. 644 minus 3240. We get negative 2596. It's negative 2,596. All right, divide both sides by negative 59. I get 44. So x is 44. So that tells me that there are 44 students that fit in a bus. Okay? And since I already solved for y up here, this is the easiest place to go back and find y. Is take this 44 and go plug it in right there. Sorry, you can't see it. So negative 7 times 44 plus 324. And we get 160, what is that, 164? Can't see the edge of it. No, it looks like maybe 16. Maybe that's 16. Let's make sure that makes sense. Well, easy way to check that is multiply. 16 times 59? No, that's not 16. I don't know what happened there. So let's try again. 2596 divided by 59. Oh, that was the x, I'm sorry. This is me going back up here. Okay, y is 16. Does that make sense? Negative 7 times 44. Maybe I didn't type something right. Maybe this calculator's being sensitive. Plus 324. That seems like that would be 16. Yeah, that's 16. Alrighty, and there it is. You can always go back and take those two numbers and plug them both in up here and make sure it works for both equations. It has to work for both. So I hope this has helped you in your quest to solve these word problems. Please let me know if I can help further. Talk to you later.